Hello my dear students, I will take one more example on T section. A T section 100 mm by 100 mm by 20 mm is used as a strut of 12 meter long with both ends fixed. Calculate the crippling load if Young's modulus for the material be 210 GPa. Okay, this is the T section given and flange of size 100 into 20, and this is web size is total it is 100, so 100 minus 20, that is web size, that is 80 into 20. Okay, in the T section, for T section, what you have to do, first you have to locate the position of the neutral axis. Okay, so how to locate the position of the neutral axis? You have to calculate y bar, that is equal to a1 y1 plus a2 y2 divided by a1 plus a2. For this, first let us assume this neutral axis is lies at the bottom. This is just an assumption. Can assume at the top also, no problem. I'll assume the neutral axis lies at the bottom layer. Okay, now we'll see here, use this formula. What is A1? This is the section 1, this is for section 1 and this is section 2. Okay, A1, what is that? 20 B into D, a rectangle area, 20 into 80 into y1. What is y1? Distance from CG to the neutral axis. The distance from the CG means CG is, what is CG for this section? That is total here this length is 80. So 80 divided by 2, that is 40. So CG will be at the distance of CG will occur at a distance of 40 millimeter. Okay. Now distance from neutral axis to that CG, that is y1. So here this somewhere here this the position of the neutral axis. First calculate that. What is the distance? 80 divided by 2. Somewhere here it is. Okay. So that is, I'll show you here. Suppose this is the position of that CG. So the distance from here to here, that is y1. Okay, this is y1, so that distance is 80 divided by 2, that is equal to 40, plus this is section 2, that is area, first 100 into 20 into, now y2 means distance from the CG to this neutral axis here, that is y, this is y1 and this is y2. What is this CG location? To full it is 20, so 20 divided by 2 is 10. Okay, so the distance from the CG to the neutral axis is now 80 plus 20 divided by 2. Okay, so that is equal to 90. So divided by a1 plus a2. A1 is 100 into 20 and A1 is 20 into 80 and A2 is 100 into 20. So simplify this, you get 67.78 mm. This is from the bottom because I have assumed the neutral axis is at the top bottom layer. So now YB is 67.78. What is YT? From the top, the distance is, the full distance is 100. So 100 minus 67.78, that is equal to 32.22. Okay, so this is from the top. Okay, once if you get this, you can calculate what is Ixx, right? What is Ixx for the T section here? That is BD cube divided by 12 plus A into Y square. Here there are two sections, that's why I have written summation. Summation of BD cube divided by 12 plus A Y square. Okay, let us take first this. This is the section 1 and this is section 2. Okay, so now I consider this formula for this section. What is that? BD cube divided by 12. B is 20 and D is 80 here. This is 80. The distance from here to here, it is 80. So BD cube divided by 12 plus A into Y, 20 into 80 into what is this y square now? Y is distance from the CG to the neutral axis. Now this is the position of the neutral axis, okay, that is at a distance of 67.78 from the bottom and 32.22 from the top. So now for this section, the distance from CG to the neutral axis means this distance. What is this distance? So from here to here, that is 67.78. So 67.78 minus this, that is CG distance is 40. 80 divided by 2. Okay, so that gives y. So y square, take the square of that, plus next section for this 100, b is 100 and d is 20. Okay, 20 cube divided by 12 plus area 100 into 20 into y square. Now distance, the CG is here, distance from here to here. What is the distance? Distance from here to here. Okay, this distance we want now. That is what full it is still here, that is 32.22 minus 32.22 minus 20 divided by 2. That gives this distance. Okay, y 2. So 32.22 minus 10 square, you get 3.1422 into 10 raised to 6 millimeter to the power 4. Now this is Ixx calculation. Let us do now Iyy calculation. How to calculate Iyy? Now the formula, you have to consider it as a rectangle, and formula is b cube d divided by 12. Okay, so what is for the first section? B cube, b is 20 and b cube, d is 80 now. So the first one is I have written here 80 into 20 cube divided by 12 plus for the other section, that is here 20 b cube 200 cube into 20 divided by 12, 100 cube into 20 divided by 12. Okay, because this formula is now b cube d divided by 12. Okay, that is equal to Iyy. So simplify this, you get 1.72 into 10 raised to 6 mm4. Now least value you have to consider, that is Ixx is 3.1422 into 10 raised to 6, and here it is 1.72 into 10 raised to 6. So the least value is Iyy, that is equal to 1.72 into 10 raised to 6 mm raised to the power 4. So now what you want, you have to calculate Euler's crippling load. So for that LE also required, L effective or effective length, that is equal to L effective is, here it is both the ends are fixed, so L effective is equal to L divided by 2. So L is given 12 into 10 raised to 3 divided by 2, that is equal to 6000 mm. Now you have all the values, you can substitute in the equation. PE is equal to pi square EI divided by LE square. Okay, so this is LE square. So pi square, E is given 200 into 10 raised to 3 into I is 1.72 into 10 raised to 6 divided by 6000 whole square. So you get 99.025 kilonewton. So like this you can calculate Euler's crippling load. I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.